Hi, good morning. I want to introduce chapter 31, and of course, here again, I'm presenting this from my laptop. One more thing is these are the same exact notes that you will see under, chapter 31. These are the notes. They are mainly like PowerPoints plus my comments and the problem solving. Today we will study circuits with alternating current. Alternating means, like from the name, it is keep on changing and changing in magnitude and direction, and we will see how this is going to reflect on circuit components. We will actually study today phasors, something called phasors. This was introduced in chapter, I believe, 14, and we are going to use it today. And I will say phasors simply, they are quantities that they are really changing, like they have a sine or cosine, and we want to add them. Okay, then it's basically like adding vectors representing sinusoidal functions and then adding them. And we're going to see how this is going to be done. How to use reactance to describe the voltage across a circuit element that carries an alternating current. Now, we will talk about something called reactance. We will use here inductors and we will use capacitors, and we'll see how we are going to use the reactance. And then how to analyze a circuit that having an inductor, a resistor, and a capacitor, all of them in series, a circuit with sinusoidal EMFs of different frequencies. Also, I will solve one related to parallel circuits. What determines the amount of power flowing into or out of an alternating current circuit? And this is very important. We are going to try to analyze power, output from these circuits. Finally, we are going to talk about transformers, how they work, what is the principle that they are, based on. Now, just here, the picture is showing an old-fashioned, I will believe, car where you're gonna have that tuning thing, and you are trying to receive the waves from your favorite channel. Then you are trying to make like the tuning thing, and I will say, how does a radio tune to a particular station, and how we are going to have like AC circuits different from DC circuits. What are the differences? And we will see how we are going to treat today resistors, capacitors, and inductors that they have an AC alternating current that is changing with time, like a sine wave or a cosine wave, and how this is going to affect the voltages and currents through them. First here, let's describe what is really the output of an AC source. And an AC source, as I said, it is providing us with what is called alternating current. And I will say in the first cycle, you can see here that the voltage is positive, then this one is plus, this one is minus, then this is the direction of the current. Whereas here, okay, there is always a turning point or like a 0 point, and then I will say we're gonna have the voltage 0, and then finally the voltage is gonna reverse, and then here we're gonna have the negative, here the positive, and this is really the half cycle. Then an AC source that you are going to see, like you're going to see this sign always now in this chapter. It is a device that supplies a sinusoidal varying voltage, means it will vary as sine or cosine. This is here showing you the voltage. I want you to differentiate between the two terms, and this is like really one of the things that was really very clear in the last exam, where you were not able to differentiate or like show me that there is a difference between different variables. Remember, here we might use V for many things like speed, velocity, voltage, whatever it is. Here, I would say mainly we are going to represent only voltage, but there is a difference between the two, the lowercase here and the uppercase. The lowercase is going to show you the instantaneous potential difference or voltage. Okay, then it's the instantaneous, which means the voltage at any point. V here, it is called the amplitude, the voltage amplitude, which is the maximum value. Okay, and cosine omega t. Omega, of course, is the angular frequency, and it is measured in radians per second, equals 2 pi times the frequency, or 2 pi over the period. In the United States and Canada, commercial electric power distribution systems usually use the frequency as 60 hertz. Then all your appliances or the things in home and the school and everywhere, we are using 60 hertz. Now, the corresponding sinusoidal alternating current, of course, is going to be I. It is, again, the instantaneous I cosine omega t. And again, this is really the dependence of voltage and current of an AC source. Now, to represent sinusoidally varying voltages and currents, we define rotating vectors called phasors. Then this is a phasor. This magnitude here, it is representing the maximum current I, which is the one that we were in the equation here. This is the one here, and it actually, this is the omega t here. It's the angle that we have. Remember, we said cosine omega t, and that phasor, it is rotating with a frequency f and angular speed omega, that is 2 pi f. The projection at any time into the x-axis is going to show you the instantaneous current, okay, which is I equals I cosine omega t. This is like basic trigonometry. And here, this is like showing you the phasor diagram for the current. Now, to calculate the RMS value of a sinusoidal current. Now, I will say the sinusoidal current, it is keep on changing. Then it doesn't have like just one value, and therefore we need always to have kind of a statistical value. It has to do with kind of an average. We call it IRMS, and we will use it throughout this chapter. RMS stands for root mean square. Now, how are we going to obtain the value? If we're going to assume this is the actual function of the current, I is the maximum, here is 3, then this is I equal I cosine omega t. In the first step, we are going to square the instantaneous current, and therefore we're going to get this equation, this function here, 2. All right, and that, look here, this is the current. It was 3a, now it is 9a squared. After that, we are going to take the average or the mean of the value of I squared. Then this is 3 here. Can you see it here? 3, this is the average for all the values that we have on I squared. And then we are going to take the square root of that average, which is which is the VRMS. Okay, then this is really and finally, I will say the IRMS is going to be the maximum current here, which is I divided by the square root of 2. Because in many questions that I did solve, we need to calculate that. Here I'm showing you, just again the same steps. I'm telling you that just to calculate the root mean square, we square the instantaneous current. Okay, the instantaneous current was presented in graph 1, and then Okay, I did repeat that actually. This is graph number 1, and then we square the instantaneous current in graph 2, take the average of the value of I2, which is graph 3, and take the square root of that average, which is graph 4. We will say IRMS is never negative. I squared it because it is I squared always, it is positive. I'm showing you here also that I equals I cosine omega t, and then when I square, of course, anything that is negative is going to be gone. And then from trigonometry, we know that cosine squared the angle equals 1/2, okay, 1 plus cosine 2 times theta, and therefore I can write this as I squared equals I squared the what is called like the current amplitude squared times 1/2, and then I was able to find what is really I squared. Now also I will say the average of cosine omega, because remember cosine, it is an angle that's changing positive and negative, then the average of cosine to omega t is 0, because it is positive for half of the cycle, negative for the other half. Then the average of I squared here is going to be I squared over 2, and then the VRMS can be calculated as the square root of this value, which is I, which is the current amplitude, divided by a square root of 2. Then here for sinusoidal AC sources, the RMS current and voltage values are IRMS equal I divided by square root of 2, and then for the VRMS, it is V divided by a square root of 2. This wall socket has a voltage amplitude of V 170, meaning that the voltage alternates between 170, the maximum positive, and 170, the maximum negative. The RMS value, it is 120, which is the one that we are using here in the United States. Okay, I'm gonna stop here and then record another one.